What on earth is going on with the Earth? The planet beneath our feet is behaving extremely strangely right now. Satellites are detecting gravitational anomalies that shouldn't really exist. The Earth's magnetic field has a huge hole in it, and mysterious signals are emanating from the Earth's deepest depths. Today we're going to take a very close look at what's happening, and we'll get right to it. Right beneath our feet, things are constantly bubbling, vibrating, and changing. And sometimes we only notice it when sensitive instruments in space sound the alarm. And for some time now, there have been increasing signs that a pole shift might be imminent. By the way, if you find these earthly processes just as fascinating as I do, be sure to subscribe to the channel. It costs nothing, you won't miss any more videos, and you'll be helping me out a lot. And if you're already subscribed, giving the video a thumbs up helps a lot. Let's try to hit 5,000 likes. Thanks a lot, everyone. Let's start with a discovery that has caught the attention of geologists worldwide. Researchers led by Charlotte Gant-Guerin from the University of Paris have discovered an anomaly in Earth's gravitational field that has developed at breakneck speed. To do this, the scientists analyzed data from the GRACE satellites. These are two satellites that orbited Earth in formation between 2002 and 2017, measuring the tiniest changes in the gravitational field. They continuously transmitted microwave signals back and forth, enabling them to determine their mutual distance with micrometer precision. When gravity changes because mass shifts somewhere, the front satellite moves slightly differently than the rear one. And from these tiny changes in distance, researchers can then draw conclusions about mass shifts within the Earth. In January 2007, a gigantic signal suddenly appeared in the eastern Atlantic. This gravitational anomaly stretched over 7,000 kilometers in a north-south direction, and this anomaly developed within just 2 years. How can such a massive anomaly form in such a short time? Is the signal even real? What's truly remarkable about the discovery is that the signal coincided with a geomagnetic jolt, a sudden change in Earth's magnetic field which was also observed in the same region in 2007. At first, the researchers considered whether the anomaly might stem from water movements at the surface. After all, ocean currents and the water cycle constantly cause changes in the gravitational field, but none of the hydrological models the scientists ran fit the data, since such signals would be at most half as strong, nor could the positions straddling the boundary between continent and ocean be explained by water movements. After careful analysis, the researchers reached a fascinating conclusion. The source must lie deep within the Earth, more precisely in the lowest part of the Earth's mantle at a depth of about 3,000 kilometers. The scientists suspect that it involves a phase transition of a mineral called bridgmanite. Bridgmanite is the most common mineral in the lower mantle, and under the extreme conditions there, can exist in two forms, as perovskite and as post-perovskite. The transition between these two forms is highly temperature dependent and is accompanied by a change in density of about 100 kilograms per cubic meter. Very technical, I know. The researchers hypothesized that in the region of the African deep mantle convection current, thermal anomalies, that is, areas with slightly different temperatures, rose upward. When these areas reached a certain depth, the pressure changed in such a way that the mineral suddenly recrystallized from perovskite to post-perovskite, so it's the same material but packed more densely, and this phase transition then generated the massive mass shift that the satellites detected. The fascinating thing is that such a phase transition could occur surprisingly quickly. Larger areas could undergo the transformation within a single day. The researchers calculate that two regions, each about 1,000 kilometers in size and just 1 degree colder than their surroundings, could cause the perovskite-post-perovskite boundary to drop by 180 meters as they rise. And that would fit perfectly with the observed gravitational signal. This discovery is incredibly exciting for several reasons. First, it shows that processes can occur deep within the Earth's mantle that are much faster than previously thought. Second, there could be a connection to the geomagnetic jolt observed at the same time, which would mean that processes in the deep mantle can influence the Earth's magnetic field. Third, such phase transitions could deform the boundary between the solid mantle and the liquid outer core. And fourth, how cool is it that we can use satellites in space to measure massive upheavals inside our planet? But this first anomaly is just the beginning. The Earth has another very specific problem. For years, NASA has been observing a mysterious anomaly in the Earth's magnetic field known as the South Atlantic Anomaly, or SAA for short. This region stretches from South America to Southwest Africa and is characterized by a dramatically lower magnetic field strength compared to the rest of the planet. Imagine Earth's magnetic field as a giant invisible shield that protects us from the sun's high-energy radiation known as the solar wind. Normally, our magnetic field traps these particles and directs them toward the magnetic poles, where they become visible as beautiful auroras, for example. In the region of the South Atlantic anomaly, our protective shield is, so to speak, dented, which is why the particles can penetrate deeper into the atmosphere there. For satellites orbiting the planet in low Earth orbit and passing through the anomaly, however, this magnetic pothole is problematic. In this region of weakened magnetic field strength, the satellite's electronics become more vulnerable to strikes by high-energy particles, which can lead to short circuits and system malfunctions. In these regions, satellite operators must routinely shut down systems before flying through this anomaly zone. NASA mathematician and geophysicist Weijia Huang explains that the observed SAA can also be interpreted as a consequence of the decreasing dominance of the dipole field in the region. More specifically, a localized field with reversed polarity grows strongly in the SAA region, making the field intensity very weak, weaker than in surrounding regions. The primary source of our magnetic field is a swirling ocean of molten iron in the Earth's outer core, thousands of kilometers below the surface. The movement of this mass generates electric currents, which in turn generate the Earth's magnetic field, but apparently not uniformly. Beneath the African continent, at a depth of about 2,900 kilometers, lies a gigantic reservoir of dense rock known as the African Large Low Shear Velocity Province. This massive rock formation presumably disrupts the generation of the magnetic field. As if that weren't complicated enough, this effect is further amplified by the tilt of Earth's magnetic axis. The anomaly is also not static, but is constantly changing. Studies have shown that the SAA is slowly moving around, and that's still not all. The anomaly appears to be splitting. In 2020, researchers discovered that the SAA is splitting into two distinct cells, each representing a separate zone of minimal magnetic intensity within the larger anomaly. The anomaly also poses a challenge for the astronauts on the ISS. The ISS orbits Earth with an orbital inclination of 51.6 degrees and requires additional shielding to deal with this problem. The astronauts report seeing strange flashes of light before their eyes as they travel through this region. The Hubble Space Telescope is also affected and does not make observations with its sensitive UV detectors while flying through the SAA. There is strong evidence that this phenomenon is not all that new. A study published in 2020 suggests that the anomaly is not a modern event, but a recurring magnetic phenomenon that has been affecting Earth for 11 million years. If that's true, then it could mean that the South Atlantic anomaly is not a trigger or harbinger of a complete reversal of the Earth's magnetic field. Such pole reversals do indeed happen, but usually only every few 100,000 years. During the last confirmed complete pole reversal, about 780,000 years ago, our ancestors apparently survived it quite well. Otherwise, we wouldn't be sitting here watching YouTube videos right now. But if it were to happen again today, it would cause significant damage in our highly technological world. At some point, such a pole shift will occur again. But exactly when? No one can say for certain. Research into the SAA could provide us with valuable insights into the complex processes taking place inside our planet that generate our magnetic field. It helps us better understand how the magnetic field has changed over time and, above all, how it might evolve in the future. This knowledge is not only important for astronomy and geophysics, but also has very practical applications for space travel and the protection of our technological infrastructure. But let's turn to an anomaly that lies much deeper. It began in 2019 when Chinese researchers in Wuhan recorded some very strange readings from the Earth's core. They discovered a fluctuation that occurs roughly every 8.5 years and could be described as a wobble of the core. Overall, the Earth consists of three main layers: the crust, the mantle, and the core. These layers have different densities and possess distinct chemical and physical properties, which are influenced by geological processes such as plate tectonics and volcanism. The Earth's core is the innermost layer, consisting of iron and nickel, and maintaining a temperature of about 5,500 degrees. The core is divided into two regions, the outer and inner core, with the outer core being about 2,300 kilometers thick and liquid, while the inner core is solid and has a diameter of only 1,000 12,200 kilometers. The inner core plays a crucial role in generating the geomagnetic field. This is referred to as the geodynamo. Previous models assumed that the Earth's core rotates along the same axis as the Earth's mantle, since both layers were thought to have a uniform density distribution. What the Chinese researchers have discovered, however, is quite revolutionary. By precisely mapping minute changes in the Earth's rotation, they concluded that the Earth's core is tilted by 0.17 degrees relative to the mantle. The density structures are quite different from what we thought, and the relationship between the Earth's core and mantle must therefore be completely redefined. One of the most exciting conclusions from the research is the hypothesis that the Earth's inner core is denser and heavier in the northwestern hemisphere than in other regions, and it is precisely this asymmetrical distribution of density and mass that could explain why the Earth's core appears to wobble every 8.5 years. And this has truly significant implications for numerous other processes on Earth. Such regular wobbling could affect the stability of the Earth's axis. A change in the tilt of the Earth's core could theoretically lead to a change in the tilt of the Earth's axis over time. The Earth's axis moves back and forth anyway over the course of a year by about 10 centimeters. Over longer periods, it is also influenced by the gravitational pull of the Moon and the Sun, a phenomenon known as precession. But in recent years, the Earth's axis has also been behaving extremely strangely. Since the mid-1990s, its drift has changed dramatically. It shifted about 10 degrees to the east. Scientists have been pretty stumped by this so far, but perhaps this new research is the missing piece of the puzzle. And then, of course, there's also the potential impact on the Earth's magnetic field. The magnetic field is crucial for life on Earth as it protects us from harmful radiation from space and shields the atmosphere from the solar wind. If the Earth's core wobbles every 8.5 years, and in the process the density or mass distribution within the core may even change, this could obviously have consequences for the currents in the liquid core, thereby directly influencing the dynamo process and the Earth's magnetic field. One possible effect could be a change in the strength or direction of the magnetic field, and that in turn could affect animal navigation, the operation of electronic devices, and the propagation of cosmic radiation. Furthermore, the wobble of the Earth's core could also lead to instability in the magnetic field. Of course, we are still in the realm of pure speculation here, and further investigation will be needed to determine what this new finding means for the Earth's magnetic field. I could imagine that these new properties of the Earth's core play at least some role in the strange behavior of the magnetic field in recent years. When we talk about anomalies, there's one place we simply can't leave out: Antarctica. Normally, temperatures in the stratosphere above Antarctica drop to around -80 degrees in winter, but on July 7, 2024, scientists were stunned when they looked at their measurement data. Temperatures in the middle stratosphere had suddenly risen by 15 degrees Celsius. This was the earliest stratospheric warming ever observed in the entire 44-year dataset. On August 5th, there was another temperature spike, this time by as much as 17 degrees. These sudden warmings in the stratosphere could have massive impacts on the entire climate system. The likely trigger for all of this, the polar vortex, a gigantic wind system that forms over the poles every winter. In Antarctica, these winds race around the South Pole at speeds of about 300 kilometers per hour. Normally, the polar vortex follows a nice round path around the pole, but in 2024, the polar vortex looked as if it had had one too many. Instead of its usual round shape, it had stretched out. This deformation of the polar vortex could have far-reaching consequences for the entire planet. One of these consequences, by the way, concerns something you all know, even if you've never seen it: the ozone hole. Normally, the ozone hole begins to form over Antarctica in early August. Researchers from the Copernicus Atmosphere Monitoring Service found that it didn't develop until the end of the month. A strong, stable polar vortex ensures extremely cold temperatures in the stratosphere. This cold is one of the prerequisites for ozone depletion and thus for the formation of the ozone hole. However, when the polar vortex is weakened and distorted, these processes are disrupted. Now you might be thinking, great, no ozone hole, problem solved, but it's not quite that simple. The ozone layer protects us from the sun's harmful UV radiation. However, its annual thinning is part of the Antarctic cycle. If this cycle is disrupted, it could have unpredictable consequences for the global climate system. Everything is connected. Scientists suspect that unusual weather patterns in the troposphere, the lowest layer of the atmosphere where weather occurs, could be responsible for the disturbances in the stratosphere. In fact, July 2024 was unusually warm in Antarctica. For the entire Antarctic region, it was the 5th warmest July on record. Variations in sea surface temperatures and sea ice could disrupt these large-scale weather systems in the troposphere, which then spread upward. In other words, we know that something unusual triggered this anomaly, but we don't yet fully understand why. However, there is strong suspicion that a singular event contributed significantly to this anomaly: the eruption of the Hunga Tonga undersea volcano in the South Pacific in 2022. According to NASA, the eruption plume reached a height of up to 58 kilometers, extending into the mesosphere. In addition to ash, the volcano released a variety of gases, including sulfur dioxide, hydrogen chloride, hydrogen fluoride, and carbon dioxide. These gases can spread throughout the atmosphere and affect both air quality and the global climate. In the case of Hunga Tonga, however, a large amount of water vapor was ejected into the atmosphere, and we know that water vapor in the stratosphere can contribute to the formation of polar stratospheric clouds, which consist of tiny ice particles and in turn create an environment where chemical reactions can occur that accelerate ozone depletion. And it seems likely that this event contributed significantly to the Antarctic anomaly. Scientists will carefully analyze the data from this unusual Antarctic winter, and perhaps they will then find further clues as to how the climate system will behave in the future. First and foremost, this shows how important it is to continue researching and monitoring our poles. The polar regions play a key role in the global climate system, and changes there can have far-reaching consequences, even affecting us here. It also underscores just how complex and delicately balanced our climate system is. A small disturbance here can trigger major changes elsewhere. I hope you're now total anomaly experts. Our planet has quite a few mysteries to offer right now. I'll keep you updated on all the other earthly secrets right here on the channel, so be sure to subscribe now. And speaking of Hunga Tonga, we only touched on it briefly today, but that volcanic eruption is a story in itself. Scientists have just discovered that it has permanently altered the global climate with noticeable effects worldwide, and that we could use this to actively change the global climate. You can learn all about this crazy story in the video shown in the top right corner. Be sure to click on it. It's very, very exciting. And if you'd like one of the galactic Astro-Tim shirts from the Plush Planets videos or a signed copy of my books, feel free to check out my space shop in the bottom left corner. Every order really supports my work. Otherwise, I'd say see you in the next video. Take care, everyone.